In this set of notes, we'll be talking about surface area and volume for spheres. And these formulas really only require you to find the radius. That's really all you need to figure out the surface area and volume of our spheres. It's really important that you just pay attention when we're doing surface area, the keyword area there. We're going to make sure that our radius is squared. In a little bit, we're going to do the volume and our radius will be cubed. So pay attention to which formula you're using. And again, you just have to find the radius. And that's practically it for this section. So let's just jump right into it. Finding the surface area of the sphere. So again, I'm going to identify the correct formula first for pi r squared. In this case, r is already given to me, so it's just a substitution problem. So I have 4.5 squared, and go ahead and put this in the calculator. It's really important that you practice doing this. Use parentheses. They are super important in this, just so that your calculator knows exactly what you are squaring. In this case, your answer should be 254.5, and we're running to the nearest tenth, so 1 decimal place. That's why I just did 0.5. The units are inches, and they are squared because surface area is still talking about units squared. Okay. Example 2, same thing, making sure I'm using the correct formula for pi r squared. In this case, my radius right here, half the circle, 6.25, and then I'm squaring that. And we are again rounding to the nearest tenth. So my surface area comes out to 490.9 inches squared. And that's pretty much it. So it's nice when the radius is given to you and it's just substituting into the formula. Now the next example, it's asking me to find the surface area of the hemisphere. So hemisphere just means half the sphere. Okay, so we are going to use the exact same formula and then just cut it in half at the very end. So if my formula is 4 pi r squared, all I'm going to do at the end is slice it in half, and that will take care of this problem. So I have 4 pi, the radius is 3.7. I'm going to square that, and then I'm going to divide it in half. Okay, so this gives me 86.02. Now, this sphere, okay, so it's just thinking about going around the globe. What happens when you cut the sphere in half? Let's say you took a ball and you cut it in half. There's going to be a hole, right? But we have to assume that this hole still needs to be filled up. So we're not just quite done. We found the surface around the ball, but if we were to patch it up to become a hemisphere, so there is no hole, then I would still need to find the area of the circle. So I need to add the area of the bottom part, the circle, to it. To find the area of the circle, it's just pi r squared, right? In this case, that would be pi. The radius is still 3.7. And then squared. So all together, when I add both the above area, the hemisphere, and the flat surface, you should get 129.0 when you round. And these are millimeters squared. So really quick, let me get you what you should have gotten for the area of the circle alone. That was 32.17. Then you add them up and make sure you are rounding. It doesn't tell you which one, but just 1 decimal place so that we can stay consistent here. And that is your final answer. And a quick fix here. This was not the right one. I didn't put the right numbers in the calculator. I actually got 43 for that one. So 43 and 86 gives me that 129 millimeters squared. Okay. So finding the hemisphere, it's great, but assuming there's going to be no hole, I have to figure out how big the circle should be so I can cover the bottom there. All right, find the surface area of the sphere if the area of the great circle is approximately 220 square meters. So the difference in this question is that I'm not given the radius, I'm just given the area of this circle. So working backwards, if the area of this circle is pi r squared, and I know the area, I'm going to use this information to solve for r. So I'll be dividing both sides by pi. That gives me about 70.03, that's r squared, and then I take the square root. That's how you get rid of the squared there. That gives me 8.4. So that's an extra step before I can actually substitute that value into the surface area. So 4 pi r squared. Now that I know my radius, I can put that in and square the value. So I'm just going to round to my whole number, and that's 880. These are meters squared for my surface area of the sphere. Okay. So that's it for the surface area. Now we're going to do volume. So here's where I was talking about just being careful that for volume, it's r cubed. I know when you're doing a lot of problems going really fast, it's easy to miss between squared and cubed. So just be careful. The volume should be cubed. So jumping right into the examples here, we have find the volume of a sphere with a great circumference of 30 pi, round to the nearest tenth. So the circumference, again, is given to me, but I need to figure out the radiuses so I can put it back into my formula. And I'm just going to put the formula at the top. So I know that circumference is 2 pi r. And this time I know that my circumference is 30 pi. So working backwards to solve for r, I would divide both sides by 2 pi. That's going to cancel on the right, and then the pi's are going to cancel, so I really have 30 divided by 2. You could also just put it in the calculator. Either way, it's going to give you that the radius is 15. The volume is now going to be 4/3 pi r cubed. Again, careful with that cubed. Use parentheses here if you need it. Putting it into the fraction, you can just enter it as parentheses 4 division 3 close parentheses and then the pi and so on. Whatever you need to do, as long as you get 14,137.2 centimeters cubed. Don't forget that cubed because we're talking about volume. It's a really big number. That's a V for volume. And then we did round to the nearest tenth for this one. All right, let's keep going. The next one's nice because it's just asking me for the volume, run to the nearest tenth, and it's giving me the radius, so I don't have to do a lot of work. Just put it into my formula. So 4/3 times pi times the radius being cubed. Straightforward, right into my calculator. So go ahead and pause here so you can practice putting it in. And hopefully this is the answer that you got. Rounding to the nearest tenth again, that's centimeters cubed for volume. All right. The last problem we have is a word problem. So we have the jungle gym outside of Jada's school is a perfect hemisphere. So remember that's half a sphere. Okay, there we go. It has a volume of 4,000, and then that's supposed to be a pi there. It looks funky on your notes. Cubic feet. What is the diameter of the jungle gym? So I know that my volume is 4/3 pi r cubed. Now, this is a hemisphere, so I have to take that and then divide it by 2 so that I make sure I'm only counting half of the volume. Okay, so in this case, that comes out to be 4,000 pi, and we have 4/3 pi r cubed over 2. I'm going to multiply both sides by 2 first. That's going to go away. That's going to give me 8,000 pi on the left and 4/3 pi r cubed here on the right. Next, I'm going to divide out the pi because that's going to make it go away on both sides. So I really have 8,000 equals 4/3 and then r cubed. Now, the way that we're going to get rid of the 4/3 is you can divide by 4/3 or think of it as multiplying by the reciprocal. So multiplying by 3/4. And you can do that as divide or multiply by 3 first and then divide by 4. So that's going to cancel it over here, and this is going to give me r cubed on the right. when I do 8,000 times 3 and then divide by 4, I get 6,000. And then to solve for r from there, I can just take the cube root. So cube root, similar to the square root, but with a 3. To put this in the calculator, you're going to have to do 3 and then find the button that looks like this. It's like an X in front of the radical, and then you would just get this in the calculator. So find the cube root of 6,000. You should be able to just type that all in, and it's going to give me 18.2 approximately. Now, our question is asking me for the diameter, and we know the diameter is twice the radius. So my last step is going to be to multiply that 18.2 by 2. So the diameter is 36.3. This is in feet this time. And don't have to cube or square anything because it's one-dimensional for the diameter. That's my answer. So this one was a few extra steps, and realizing that I had to divide the volume by 2 in my formula because the volume is really only for the hemisphere. So I have to divide my formula by 2 to begin with. And that's the end of these notes.